All right, today's screencast is going to be about the cost of production. And this is going to be our opening chapter in Unit 4. Unit 4 is called The Theory of the Firm. It's also called Industrial Organization. And what we're going to be studying is how firms or producers think, kind of how producers act when they're actually producing goods and services. So really what we're going to be looking at is kind of the industrial behavior that underlies the supply curve. How do actually different firms operate? Now, the goal of a firm, this is really important, it's really simple. The goal of the firm is to maximize profit. Okay? So when you ask a question, how many units should a company produce? As many as it takes to maximize profit. How many workers should a company hire? As many as it takes to maximize profit. Company doesn't particularly care about how many workers they have or how much production they have. What they care about is how much profit they have. So the goal of a firm is to make as much money as they possibly can. This is a really, really simple concept, but it's one that kind of eludes a lot of people. A lot of people don't really quite get that the firm doesn't care one way or another about actually employing people or about producing goods and services. They care about profit. And how do we define profit? The simple definition. Okay, we're going to look at some more complicated definitions that we're going to take into consideration a little bit, but the simple definition is its total revenue minus the total cost of production. So let's say my revenue is $1,000, my total cost of production is $500. Okay, that means my profit would be equal to $500. Total revenue minus total cost of production. But there are actually multiple types of profit we need to look at, and kind of or multiple types of costs, excuse me, we need to look at. Kind of to start with, we're going to look at explicit costs versus implicit costs. Explicit costs actually require the firm to spend money. Okay, so explicit costs are measurable. Whoops. Explicit costs require the firm to actually spend money. You can measure an explicit cost of production. Implicit costs are opportunity cost. Okay, they're not necessarily measurable. Okay, now, one important thing you need to know, one important thing you need to remember is there's always going to be an opportunity cost. So firms always have some form of implicit costs. So when it comes to implicit and explicit costs, this is a big difference between accountants and economists. Accountants really only look at the explicit cost of production. Okay? Economists look at both the explicit and the implicit cost of production. Okay, so accountants are going to look at the explicit cost of production. Economists look at both explicit and implicit costs. Now, there's always going to be an implicit cost of production because there's always going to be an opportunity cost. As a result, accounting profit is always going to be greater than economic profit. So, real simple scenario, we may say in the long run, firms can earn zero economic profit. Economic profit is profit beyond ordinary profit. Really, really huge profits, okay? So in a competitive market, it's very hard for a firm to make economic profit because other companies are going to enter the market. But if economic profit is zero, accounting profit has to be positive, okay? When we look at it on a graph, it kind of looks like this. We've got how an accountant views a firm. So we have all of our revenue. We subtract from our revenue our explicit cost. That leaves us our accounting profit. Okay? An economist is going to take the same revenue. They're going to subtract from it both the explicit and the implicit costs, which is right here, the implicit costs, right? And that's going to leave significantly less profit, right? So the economic profit is always going to be less than accounting profit. So even if economic profit is zero, accounting profit is going to have to be positive. Now, so why does a firm incur costs, right? Why does a firm incur costs when they're producing goods? And the short answer is they incur costs because they have to. So they need to produce goods and services. And the costs are really going to be the costs that they use, the cost of the factors of production that they use. And the factors of production are going to be land, labor, and capital. Okay? So firms are going to use land, labor, and capital to produce output. Whatever the good or service that they're producing is going to require them to take land, labor, and capital and combine it to make something of value. Okay? For our purposes, we're going to really focus on labor right now. It's kind of the easiest for us to measure, but the rules that we're going to set up apply to land and capital equally as well. Okay? So the production function is a graph we use to demonstrate how firms employing labor or land or capital, really any factor of production, how their productivity changes as they increase in input. So what does an increasing of an input do to the amount of output the firm can produce, the amount of goods and services that the firm can actually produce? Now, we really, when we were looking at the production function, we're looking at what's called the marginal product. Okay? And the marginal product is the additional production that we get, the increase in production we get from an increase in an input. How much extra production do we get when we increase in input, land, labor, or capital? And the formula for the marginal product is the change in output over the change in input. And delta, is the mathematical symbol for change. Okay? And the production function really shows us the relationship between, or it's important because it shows us the relationship between a firm's productivity and its cost. And this becomes really important when the firm decides whether or not to produce a good and what price to set that good for. Okay? And the total cost curve shows us this graphically. So the marginal product is, again, the change in output over the change in input. So change in output over the change in input. Okay? So as I go from 0 to 1, workers, that's my input. Okay? My number of workers goes up by 1. My number of output goes up by 50. This would be 50 over 1. Marginal product is 50. So I go from 1 to 2. My number of workers increases by 1. My output increases by 40. My marginal product is 40. Okay, here it's 30. If you notice, my number of workers is always increasing by 1. Okay, 20, 10, and then 5. Okay? Now, total cost is just going to be the cost of the factory plus the cost of the workers. 30 plus 0, 30. 30 plus 10, 40. 50, 60, 70, 80, 90. Okay? Now, when I graph my firm's production function, it's going to look like this. Okay? Whoops. And the way I would describe this is it's increasing at a decreasing rate. So if I look, as I go from 0 to 1 worker, my first worker gives me 50. As I go from 1 to 2, that worker gives me 30. Okay? And then that worker gives me, pardon me, this one gives me 40, and then 30, okay, so on and so forth. So it's increasing, but it's increasing at a decreasing rate. Now, my total cost curve is going to look a little bit different, okay? My total cost curve is going to increase at a increasing rate. So it goes up slowly, 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 and the more I produce, the more quickly my total costs of production actually increase. And if I look at my production function and my total cost curve, I can see that they're inverse of one another, right? They're mirror images. So this is increasing at a decreasing rate. This is increasing at an increasing rate. This increasing at a decreasing rate that you see in the production function is actually called the law of diminishing returns, okay? And because of the law of diminishing returns, we see the total cost curve is increasing at an increasing rate. That's called an exponential increase, okay, for those of you enjoying math. We're going to actually do a little activity in class that demonstrates the law of diminishing returns. I'm going to give you guys a little bit more information. The main reason the law of diminishing returns happens is, let's say I'm adding labor, okay, let's say I'm adding labor. In order to get value out of my labor, I also have to add land and capital at the same time, right? If I just add labor, I'm actually not going to get too much value out of that labor because they're going to need an area to work and machinery to use to actually increase their productivity. Now, from a business point of view, there are a couple other ways we can look at costs of production as well. Costs can be divided into fixed costs and variable costs. Fixed costs are costs that really don't change, at least in the short run. So fixed costs, no matter what, over a short period of time, you have to pay. Kind of the classic example of a fixed cost is going to be rent, right? Classic example of a fixed cost is rent. Other examples are managers' salaries, insurance, okay? No matter what, okay, even when you're shut down, even when you're not operating or closed for the night, you got to pay your rent. Variable costs are costs that do change, okay? Kind of the classic example of a variable cost is wages. So this is an hourly worker who gets sent home because it's slow that day, right? Businesses really do focus on limiting their variable costs, keeping their variable costs as low as they possibly can. Now, total cost is simply fixed costs plus variable costs, right? Total cost is fixed cost plus variable costs. Really, firms want to minimize their total cost of production, but the way they do that, because variable cost is the cost that change, is the firms actually focus on keeping their variable costs low. So here, my total cost would be my fixed costs plus my variable costs. So it'd be these two columns together. Here it'd be $3. Here it'd be $3.30. Here it'd be $3.80. Here it'd be $4.50. Okay, you guys can see how I did this. You could fill in the column the rest of the way on your own. Now, average costs is going to be whatever that cost is. You could have average fixed, average variable, and average total, okay? And it's going to be divided by the quantity of output, okay? Divided by the actual quantity produced. The average cost tells us how much the typical unit is going to cost us to produce. What is the typical unit cost to actually produce? So there's going to be three different average costs you're going to know. It's going to be average fixed, average variable, and average total. Okay, so to find average fixed, you're going to take fixed cost divided by quantity. Average variable is variable divided by quantity. Average total is total divided by quantity. Another way we can look at it is, since total cost equals fixed cost plus variable cost, average total cost also equals average fixed plus average variable. Okay, so average fixed equals fixed over quantity. Average variable is variable cost over quantity. Average total is total cost over quantity. Now, marginal cost is actually probably the most important cost. Marginal cost tells us how much does the next unit cost us to produce. How much are we going to spend to produce one more unit? Okay. This is really going to help firms decide whether or not they should actually produce. Okay. And the marginal cost formula is the change in total cost divided by the change in quantity. Okay, the change in total cost divided by the change in quantity. So on a chart, what it's going to look like is this. So my average fixed cost is going to be fixed cost divided by quantity. Each of these is going to begin with an empty set. Okay, so here to be $3 over 1, be $3. $3 over 2, be $1.50. Here to be $3 over 3, be $1. Okay, here to be $3 over 4. You guys get the idea. You can fill it in the rest of the way. Average variable costs, again, I'm going to begin with empty set. 30 cents over 1, 30 cents. 80 cents over 2, 40 cents. $1.50 over 3, 50 cents. Okay? Average total is going to be total cost, this column, over quantity. 330 over 1, 330. 380 over 2, that's $1.90. 450 over 3, that's $1.50. Now, if you notice, my average fixed plus my average variable equals my average total. $3 plus 30 cents is $3.30. $1.50 plus 40 cents is $1.90. Dollar plus 50 cents is $1.50. Okay, you guys can fill in this column the rest of the way on your own. Now, total cost is going to be found by finding the change in output, okay, or pardon me, the change in total cost. So I go from 0 to 1 over the change in output. So here my change in output is 1. My change in total cost is 30 cents. Okay, my marginal cost, 30 cents. Here, as I go from 1 to 2, my output increases by 1. My total cost increases by 50 cents. My marginal cost is 50 cents. Here, as I go from 2 to 3, my output again changes by 1. Okay, I go from 2 to 3. My total cost increases by 70 cents. Okay, and you guys can fill in the rest of this chart on your own. Now, cost curves in their shape. Marginal costs is going to start out by decreasing just a little bit, and then it starts to rise exponentially. So again, marginal cost tells us what the next unit is going to cost, okay? This is really reflected by the law of diminishing returns, okay? This is really showing that law of diminishing returns kicking in. So I'm bringing in extra workers. Each worker I hire, I have to pay, except the workers aren't really increasing my productivity, right? So they're raising my costs, but actually not increasing the quantity produced much at all. Now, the average total cost is U-shaped. It falls at first until it crosses the marginal cost curve, and then it starts rising. Okay, so ATC is U-shaped. It falls at first until it crosses the marginal cost curve, and then it starts rising. The bottom of the ATC is always going to be where the average total cost intersects the marginal cost. And this is called the efficient scale of production. This is the lowest cost you can produce a product for. You can't produce it any cheaper than this, okay? Called the efficient scale of production. Now, kind of my favorite example to talk about why the ATC has to intersect the marginal cost at its lowest point is to compare it to like GPA, your grade point average, and your marginal GPA, your GPA at the end of this semester. So I want you to imagine for a moment, you currently have a GPA of a 4.0, okay? At the end of this semester, you get a 5.0. Well, if your GPA at the end of the semester is higher than your average GPA has to be rising. On the other hand, if at the end of you currently have a 4.0 total overall GPA, at the end of this semester you get a 3.0 GPA, well then your average is going to have to be falling, okay? So when the marginal cost, the cost of the next unit, is higher than the average cost, the typical unit, the average cost is going to be rising. When the marginal cost is lower than the typical unit, okay, when the marginal cost is less than the typical unit, the average total cost has to be falling. So whenever the marginal cost is less than average total cost is falling. Whenever marginal cost is greater than average total cost is rising. And the marginal cost curve is always going to intersect the average total cost at the efficient scale. Okay, it has to. So the marginal cost is always going to intersect the ATC at its lowest point, the cheapest you can produce a product for. So this is what the cost curves are going to look like for the typical firm. Your marginal cost kind of looks like a Nike swoosh. Your average total cost is a horseshoe, and it intersects the marginal cost, at this point right here. Okay, this is known as the efficient scale of the firm. Okay, that's the cheapest that the good can be produced. Now, the average variable cost is also a horseshoe, and kind of show you the average fixed cost to try to explain why it's shaped the way it is. So average fixed cost is a limit. It starts out really high, so you're dividing a fixed quantity or a fixed number by an increasing quantity, right? Okay, we're dividing a fixed number by an increasing quantity. The more I produce, the lower my average fixed costs become. Okay? Now, the key to drawing the average variable cost, it's also a horseshoe. It starts out really far from the total cost curve. However, as average fixed costs decrease and gets closer and closer to zero, but average fixed costs will never intersect zero. Average variable costs make up an increasing portion of the total cost of production. So these two curves have to get closer together. The average fixed and average total costs have to get closer together. Now, three important properties of cost curves. Marginal cost is inevitably going to rise. And the reason marginal cost inevitably rises is because of the law of diminishing returns. Average total cost is a U, and ATC intersects the marginal cost at its lowest point, at the efficient scale. Now, there is one thing we need to consider when it comes to the average total cost, and that's the actual length of time that we're dealing with, okay, or what's called the time horizon. Now, in the short run, there are some fixed costs, okay? Some costs are fixed in the short run. You have to pay them no matter what. However, what happens in the long run is fixed costs become variable. Firms can shut down, firms can move into bigger factories, firms can relocate, firms can expand, they can add on, whatever, okay? Fixed costs become variable in the long run. Now, what's the difference between the long run and the short run? It really depends on the nature of the firm. If we're talking like a big industrial company like Ford or GM or US Steel, the long run's really long, okay? Firms that have lots and lots of capital, equipment, machinery, and tools, we're talking a really, really long run. If we're talking about a law firm, the long run is pretty short. Okay, it doesn't take them a long time to adjust. They can move into a new office once their lease is up. Okay, so what ends up happening is a firm's average total cost curve is really made up of a series of short run decisions. Okay, so we have, let's say, a typical industrial firm. They start out really small. They have a really small factory. Okay, what happens is average total costs fall till they reach the efficient scale, and then because of the law of diminishing returns, they start to rise. Okay? Well, what the firm can then do in a small factory is they can expand to a medium-sized factory. So once they get to this point right here, okay, right about here, they expand. Average total costs start falling again, okay, until they start to rise because of the law of diminishing returns. Okay? Now, once they get into this area where average total cost is rising, they can expand again into a large factory, and they can keep doing this. I have 3 on the graph, but we could probably put 20 or 30 or 40 depending on the firm. Some companies are hundreds of years old, okay, and they go through this process. But what ends up happening is the firm's long run average total cost is really going to be the bottom of all these short run ATCs. So here's my firm's long run average total cost, and it's going to go through 3 cycles. Okay, economies of scale, constant returns to scale, and then diseconomies of scale. So economies of scale is the property where average total cost falls as output rises. So this is going to be this downslope, right? Economies of scale, average total cost is falling as output is rising. Constant returns to scale is the property where average total cost in the long run is staying the same, okay? That's going to be this area right here. So we're expanding output, but my costs really aren't changing very much. Okay, we're expanding output, but my costs really, if we look at it from the long run point of view, aren't really changing. And then diseconomies of scale is the property where long run average total costs rise even as quantity of output increases. Okay, that's going to be this upward sloping area where average total costs start increasing. Now, what you'll notice about this is all these short run average total cost curves also have economies of scale, a small section of constant returns to scale, and then diseconomies of scale. And what happens is once a firm enters into diseconomies of scale in the short run, they expand. Okay? They get into that constant returns area, get into diseconomies of scale, expand again. And again, you could have 15 or 20 average total cost curves in the short run. Now, that'll be it for this portion of the video, for chapter 13. You're also going to have a chapter 14 video very soon. The one thing I would really tell you to pay careful attention to, you're going to need to know these mathematical descriptions, okay? And you're going to need to know the relationships, so it's really kind of important, this one in particular, the total cost equals fixed cost plus variable cost, because it's related to these average costs, okay? The other thing you're going to need to definitely know is the cost curves and their shapes. And we'll go through those a little bit in more detail in class and kind of why they're shaped the way they are. So stay tuned for the chapter 14 video.